Hello. In previous videos we covered setting up and running circuit trace applications, and in this video what we're going to do is cover script programming. So to do so, we will open the File menu and we will open an existing application, and we will go to the script view. And we could type in a script program, but just to make it easy, we will paste one in. And let's save that. We'll save as, what we're going to do is save that in the scripts folder. We'll save it as leds.txt. So if we now go over to the solutions docking panel, we will see our leds.txt, and if we had a number of them, we can switch back and forth and select one. So we have this script program. So what is it and what does it do? Well, what it does is it runs some LEDs on our board and makes them flash on and off according to a pattern that we've set up. But just to explain the script, what we've done is we've declared an integer x, a variable that we can use to control a for loop. And we have taken some scan pins on our board and assigned them to LEDs and given them a name. For example, U3 pin 74 is a scan pin. It's connected to LED, a name LED74, and we've done that with a few pins. Then what we've done is we've taken those pin names and put them in a group which we call LEDs, which we can then manipulate, and when we do, whatever value we set on the scan pin will be shown in the LEDs pin group, and hence the LEDs will flash depending on what we're doing, how we're driving those pins. So in this in the set of instructions that we have following these initial declarations, we have a drive Z, drive high impedance LED, so that would turn off all of the LED drivers, these pins. Then we've set some comments. For example, here's a loop from 1, it's actually from 1 to 45. We'll change that. 45. And in the loop, we're simply iterating our x variable from 1 to 45 and incrementing the x. So it's a simple standard programming loop. And then what we do is we have a drive group instruction, and the argument for that would be to set LEDs equal to the x value, and then drive those values out on these pins to make the LEDs flash at various values. And then we have an instruction, and this is simply a comment that's just telling us what the LED's value is. And then when we finish the for loop, we have an instruction to again tri-state the LEDs. So let's say we're going to run this, but let's say before we do, we want to watch certain variables. We can just double click on a variable, and when we run the program, the x variable value will be shown here. We may also want to watch LEDs, so we'll do that. And notice that when we click on LED pins, those pins are shown over here in our circuit view. So let's say that we want to run this. We will then go up to the script menu, and we can simply run it. And when we do, it will run through the programs and show the LED values. We can, if we want, set a breakpoint, and we'll do that here. That will set this color, and then we can run up to the breakpoint, and then if You can step through the instructions from then on one at a time. And then from any point you can click run and it will run through the program. The other thing that you can do, you may just want to run certain instructions. So you could select those instructions and just run them, or you could repeat the selected instructions indefinitely. We're going to stop that. So we have just shown how to set up and run a for loop. Within the script capability, you have if, then, else instructions, while loops, do while. You can make function calls. So you can pretty much do whatever you need to do with individual pins or pin groups in terms. We can take a quick look at some of the other possibilities and things that you can do. And for this, we'll look at other programs, for example, GPIO tap pins. In this script program, what we've done is we've declared some GPIO pins in the form of unused tap pins. So if we go over to controllers, we can see there's a channel B, and we've said let's call channel B for GPIO purposes lowercase b. So now we can come over and say declare pins. TCK, for example, we can say is equal to GPIO.B.TCK. We can do a similar thing with the other tap pins. Again, we can declare variables, and we can do drive low instruction and list the pins that we want to drive low. And notice that we're treating them just like scan pins at this point for script programming purposes. And we can test low, the TDO pin, and then we can output that. We can say TDO value equals TDO. We can drive high the GPIO pins. We can test high, and then again we can set up a for loop, drive group, tap. We set up this tap pin group equal to the individual tap pins, and we can then repeat the loop and do various things in a similar manner to what we did with the scan pin. Okay, so let's see what else we can. Let's say an if-else statement. Here, this program has some dip switches that are listed like so, and they're put into a pin group, SW, with a list of the dip switch names. And we have some LEDs as well connected to the scan pins as before. But as far as the if goes, we can do an if statement. If our pin group SW is equal to hex 5, do this, drive the group LEDs equal to the switches. Else, if the switches are equal to hex 0A, we do this. Else, we do that. So that's a simple example of an if-else. Let's take a look at a do-while, a script program with a do-while. And you can mix all these up within any program, function calls, if-else, whatever you like. In this case, we also have our bunch of switches. We're setting it to equal to pin group equal to 0 to initialize it. We're setting a variable script character, which we've declared, equal to 0, and then we're doing test the group SW. If it's equal to 0, do this. But while SW is not equal to hex 5, and the script key character, in other words, you haven't typed the key equal to Q, keep running this switch and reporting the value on the switches. Another thing we can do is a function call. And in this case, we've declared some LEDs again as variables. We're driving the group, and then we make a function call to my function, which is defined down here, and we're passing in a variable 16. So in this case, within the function, we iterate through another for loop and drive that group LEDs to the control variable in the loop. I should say that there is additional information. This is kind of a brief overview. There's additional information in online help for script programming, as for the other topics. But you can open this, and there are a number of things that you can cover and look for regarding script programming. There are also, within the Circuit Trace demos, in the examples folder, all of these script programs are included for your reference. So that's it now for script programming. Thanks for watching.